what's the difference between a receptor agonist versus a receptor antagonist? A receptor agonist causes the same effect as the normal ligand, the normal molecule that binds to it, or the normal events, and a receptor antagonist blocks, blocks. This was from one of the homework questions, and what I wanted to do is give you a sense of what that looks like. So if we have some receptor here, and maybe it has some either full or partial charge distribution, then its normal binding partner, maybe this is luteinizing hormone LH, would match in shape and charge and would bind, would fit and bind. If it's a hormone receptor protein binding, so if this is in the membrane, maybe it's a G protein coupled receptor, then we'd want high specificity. In other words, this binds, but other things don't, but not high affinity. We wouldn't want such a good match that this binds and sticks indefinitely. So what about an antagonist or an agonist? Now, agonists often are from other animals. They may be plant defensive compounds. They may be coming from bacteria or parasites, and they have the same epitope, but they have some other structural differences so that they're not the same compound. So this might be an agonist, although just from the shape, we couldn't tell whether it was an agonist or antagonist. So our agonist will also bind, and if it's an agonist, by definition, that means it will do the normal things. So it would have this G protein separate out and cause the normal second messenger cascade and the normal events. So that's an agonist. Now, the same thing happens with an agonist in terms of the binding region. So again, it would be similar enough to fit, but it would have some other shape. Again, it has to match. So the epitope, this region here is the epitope, the binding region for all three of these. That is the epitope of the ligand being whatever it is that's binding to the receptor. We define it as an antagonist if the binding here blocks this effect. That would be an antagonist for this receptor. It's an agonist if it causes the normal events. Again, you can't just look at a molecule and know whether it's going to be an antagonist or an agonist. What matters is what's the outcome. When the particular molecule binds, because it's not exactly the same as this, in some cases it may prevent a change in the G protein, and in other cases it may induce it the same way the normal ligand does. So finally, again, to remind you, these antagonists and agonists, they're often parts of, for example, venoms from a snake or something else. They can be plant secondary compounds where selection has favored something that can bind that is similar enough to a normal molecule to cause effects. And for example, you can have an agonist that causes the same effect as the normal hormone, but so much so that in the reproductive system it might make an animal infertile. Or you can have an antagonist that blocks the function, and again, you might make an animal infertile. And for a plant species that has grazers feeding on it, that might reduce the amount of grazing on it. In fact, there's a hypothesis out there about exactly that for phytoestrogens, estrogen-like compounds found in some plants.